and machine learning.
Hello everybody, welcome to an introduction to data mining and machine learning. So data mining, machine learning and knowledge discovery. There are a lot of different names for concepts that are very similar. Of course, I won't be making you experts in 15 minutes, but I hope that by the end of the presentation, you will at least have a better understanding of these terms. So this is the plan for today. I will focus on the discovery of knowledge in databases with a small example and give you an insight in machine learning. About me. So, well, my name is Jeremie. I am from Switzerland, a small but beautiful country in the middle of Europe. You should totally come and visit. Yes, I did already milk a cow and I love chocolate. I guess some stereotypes do hold up. I'm not very different from any other students here in Piguet, but except that I did 2 weeks research on machine learning before giving this presentation. Great, whoa, bossing me around already. Okay, but first let me give you a bit of context into my presentation. When you work in a company, sometimes you have to make decisions, and these decisions are often based on data. So the problem is that when you want to exploit that data, it may be too big or beyond understanding, especially in the last few years where the amount of data rose exponentially. Humans cannot keep up with it, and we can only expect it to grow even more, even larger. We call that concept big data. Big data is the notion of having too much data for traditional databases. It's too big, it moves too fast, or it just doesn't correspond to the architecture of your database. To gain value out of this data, you have to find another way of processing it. Knowledge discovery is a process or a framework that helps you transform the data into information and also helps you make predictions and decisions out of the results. It seems scary at first. You basically have a bunch of databases that you process into, let's say, an Excel datasheet, and you apply data mining over it in order to find patterns that will help you make decisions. The process is quite simple, but the analysis can be complex, depending on the type of variables you have or the dependencies. Well, of course, that's a good idea. It's better than anything else. I hope you can see, especially behind. So this is an example of a famous dataset where you have to predict if an adult is going to earn more or less than $50,000. Here you have the income. Yeah. Earn more or less than $50,000 per year, depending on these 14 variables from before. After processing the datasheet and finding the interesting values, the ones that contain information, we can then what we call mine for data. So the major steps of data mining after processing a database is to choose a specific algorithm, depending on the type of problem you have. There are a lot of algorithms, and I won't detail a lot of them, or actually any of them, but I'll maybe talk a bit more about them in machine learning. What you have to remember here is that choosing an algorithm is it's not the only important part. You also have to tweak its parameters, train it on part of the data to create a model, and apply it to the rest. Well, let's have a look of how much code we need to do that, for example. Oh, okay, you can't see much. Doesn't matter, it's not very important. This is an example of R code that I wrote. It's only 100 lines of code, but it does the trick, I would say. Don't worry too much because this is just an example. And nowadays you can create one in 10 lines of code. And whoever wants that, I can send it by email if you want. In that specific case, it gives us a model that we can use to predict an outcome. So if your relationship is a variable. So if your relationship was to be married, then you would have 93% chances of earning less than 50,000. Don't judge me, it's the algorithm and the specific data set. I didn't do that. And in addition, if your capital gain was under 7,074, you would have 95% chances of having the same. So, of course, we have to check for the accuracy and compare its performance with other algorithms, but I don't have the time to do that. Well, again, yeah, I guess you want to talk about machine learning a bit. Machine learning is a lot like data mining, but the difference is that we define the outcome of the program. We define the outcome, and the program learns the steps to go there, basically. Machine learning focuses on predictions based on known properties learned from the training data and uses a lot of trial and error, whilst data mining instead focuses on learning patterns, basically. We can basically use the steps of data mining, but add a layer of training phase where computer tries and tries all the time. Now, I'm just going to define 3 types of learning techniques. The supervised one that we can see here will get feedback all the time and will know if it's right or wrong and try to adjust, basically. The unsupervised one in the middle, the role is to receive data and model the underlying structure of the data. Okay, and the last one usually has a mix of labeled and unlabeled data and receives feedback only if the answer is correct. Well, that's true, because machine learning is very old. Well, it depends what you mean by old, but it's very old and was coined for the first time around 1959. So why is it suddenly coming back? You know, why do we have that many talks about it? The reason to that is called deep learning. Now, deep learning is the cutting edge of machine learning. To understand it, we have to start in the mid-50s when the first neuron model was created. This model inputs some information, as we can see here, a matrix of bits, sums it, and if it's over a specific threshold, will return 1 or a 0. Okay, later on, a few techniques were invented to update the weight of the information in real time, called backpropagation, thus creating what we call a machine learning algorithm, because it would come back and forth and backpropagate the weights and update them all the time. Now, today, we have different architectures for what we call neural networks that allow us to transform non-linear models to linear models by adding a lot of layers and simplifying the steps in between. Adding to that a big data set and a lot of computing power, and deep learning can outperform humans in tasks we thought only we could do, basically. So, now, machine learning is used in a wide area of subjects. New malwares tend to have the same code as previous versions. Only 10% of the files change from iteration to iteration, according to an intelligence company called Deep Instinct that I read on Google beforehand. Machine learning can analyze and predict different patterns to help security and report anomalies. It can also be very useful in healthcare, for example, to understand risk factors for disease in large populations, and is also used in recommendations and cross-selling for services such as Amazon and Netflix, that I guess you all know. Now, to break it down, we have seen that knowledge discovery focuses on decisions in companies and what we can gather from the data to help make them, basically. Data mining is a process in knowledge discovery involving the finding of patterns. And finally, machine learning wants to make predictions when we train a many-layer deep neural network on lots of data using lots of computing power. We call it deep learning. Okay. Now, finally, I just want to make another slide here. Just want to take a minute to talk about a program called Making the Most of Masters that we master's students have here in Piguet. We have the opportunity to make our master's project in a company. So if you're interested in any of the projects listed here, for example, in knowledge discovery and deep learning to assist malware prediction, which is my original goal and why I'm giving this talk, then you just need to send me an email and I'll give you more information, basically. Before the end, I'd like to know if anybody followed that. How many dogs are in this presentation? Oh, who said 7? Here you go. Okay, thank you everybody.